In this video, we're going to look at a series parallel circuit and solve for voltages and currents in that series parallel circuit. And then once you have voltage and current for an element, as we discussed earlier, you can find its power just by multiplying the voltage across the element times the current through it. So here is our series parallel circuit. You can see we have a 16-volt source and a couple of resistors here, an 8 and a 24 ohm, and then this 2 ohm here. So there's a couple of different ways we can approach a problem like this. One way to approach it is that we can first find the REQ for the source, and then once we have the REQ for the source, we can find its current, and then we can see how that current for the source will split up as it flows within the circuit. So the first thing that I did here is I took the 8 and 24, which are in parallel, and did product over sum. So if you calculate 24 times 8 over 32, that comes out to 6. So that's what I did over here, is I redrew this circuit with the 8 and 24 represented as a 6 ohm resistor. So now we can see that in this series representation of our circuit, our current flows like this, and we can find the current with Ohm's law, right? Voltage divided by resistance, where this is the REQ of these two resistors in series, which is 8 ohms. So we find that there's 2 amps flowing. So there's 2 amps flowing through the 16-volt source, this 2 ohm resistor, and also the 6 ohm that represents the 8 and 24 that are in parallel in this diagram over here. So coming back over to this diagram, we can now say that there's 2 amps flowing like this. See, there's 2 amps flowing for the source and the 2 ohm resistor in this diagram, and that's the same 2 amps flowing through the 16-volt source and the 2 ohm in this diagram. But now when that 2 amps gets to the 6 here, well, that's these two resistors in parallel. So that 2 ohm, or excuse me, that 2 amps is going to split up through those parallel resistors. And to find how that 2 amps splits up, we can use current divider equation. So you see, I can find the current through the 8 ohm. It's going to be the 2 amps flowing into the parallel combination. And using the form of current divider that has a sum in the denominator and a value of resistor in the numerator, where the value of the resistor is the other resistor. So since we want the current through the 8 ohm, the other resistor value 24 goes in the numerator, and then the sum 8 plus 24, which is 32, goes in the denominator. So the current through the 8 ohm is just equal to 1.5 amps. That's 48 divided by 32, so 1.5 amps, right? And that current is flowing down. So now, since we know the current through one of these parallel resistors, we can get the current through the other one just by KCL. If I do KCL, say I do KCL right at this top node here, right? There's 2 amps flowing in, I got 1.5 flowing out, so the current through the, actually, I drew this arrow by the wrong resistor, right? We got the current through the 8 ohm. That's the 1.5. The 1.5 amps is the current through the 8 ohm. So now the current through the 24 ohm using KCL would just be the 2 amps minus 1.5. So half an amp. Now you could also get the current through the the 24 ohm by doing current divider, where the only difference is in the ratio you'd have an 8 instead of a 24. Now once you know the currents through the resistors, you can get the voltage across them. So the voltage across the 8 ohm is just going to be 1.5 times 8, so that's 12 volts. Okay, and that voltage across the 8 ohm would be the same voltage across the 24 ohm because those resistors are in parallel, and we know that voltages are the same in parallel. So you see this would equal the voltage across the 24. Okay. Let's see, the voltage across the 2 ohm. That's just going to be 2 ohms times 2 amps, which is 4 volts. And you know, we could check our answers, our voltage answers here, just by doing KVL. If you look over at this loop here, as we go around this loop, we would go minus the plus in voltage 16, putting the polarity for the voltage across the 2. The higher end voltage is on the left side. That's where the 2 amps enters. For these parallel resistors, the polarity, the higher voltage end, would be on top. That's where the current enters those resistors. So you see, as we go do a KVL around this loop, 16 minus the plus, 4 plus the minus, and 12 plus the minus. So 16 volts minus the plus equals the plus the minus of 4 plus the plus the minus of 12. So you see the voltages balance out around that loop as well as this outer loop. And we could find what power is for any of the resistors. For example, the power for the 8 ohm would just be its voltage, which is 12, times its current. The current for the 8 was 1.5. Okay, so 18 watts. So that's an example of power for one of the resistors, and you could find the powers for the other 2 resistors the same way. Find the power being supplied by the source, and then those powers should equal, because remember, one of the conservation principles is that in a circuit, power supplied equals power absorbed. So that's a little exercise that you could do on your own for some added practice. But let's also do this problem from a slightly different approach, that instead of using current divider to find the currents and then getting voltage from Ohm's law, you could actually find the voltages first from voltage divider and then find the currents from Ohm's law. So you see, same problem, but now in this representation of the circuit as a series circuit, once the 2 parallel resistors are combined into the 6 ohm resistor, well, since this is a series circuit, I could apply voltage divider to it to find the voltage across these resistors. So for example, using voltage divider, I could find the voltage across the 6 ohm. Okay, in this diagram, it would be 16 times a ratio where 6 is in the numerator. That's the resistor we want the voltage for. And then 6 plus 2, which is 8, would be in the denominator. So the voltage across that 6 ohm resistor is 12 volts. And you see that 6 ohm resistor in this diagram represents the 8 and 24 in parallel in this diagram. So the voltage across the 6 in this diagram is the voltage across the 8 and the voltage across the 24. Okay? And likewise, we could find the voltage across the 2 ohm here with voltage divider, or by KVL, right? By KVL, it's just 16 minus 12, which is 4. By voltage divider, it would be 16 times 2 over 8, okay, which comes out to 4. So either way, you come out the same answer. And then once you have these voltages, well, now I can find the current for each resistor just by Ohm's law, that voltage divided by resistance. So you see the 4 volts for this 2 ohm resistor, divided by the 2 ohms would be 2 amps, the same as what I got over here. And then the 12 volts divided by 24 ohms is the half amp, same thing I got here. And then the 12 volts divided by 8 ohms is the 1.5 amps that we also got over on this side. So see, with problems like this, you can approach it from two different ways. You can approach it by getting the currents first, then solve for voltage using Ohm's law, or you can solve for voltage first, then solve for current. And then, of course, once you have voltage and current, power is just the product of those two quantities for each of the elements.